Ladies and gentlemen, welcome. This is our seminar number 10. Today we will continue the probability distributions, the continued probability distribution, the normal distribution, and after we will start with confidence intervals. So make ready your formulas, tables and calculator, and we can start. We will solve this example. The time limit for elaboration of the midterm test is set on 30 minutes. The period to complete the test by students has a normal distribution with mean of 30 minutes and standard deviation of 5 minutes. Okay, so normal distribution. What is it? Normal distribution. You can imagine this shape of the distribution, and here is mu, the average, yes, the expected value, expected length of the writing of the midterm test equal to 30, yes, and the standard deviation sigma is equal to 5 minutes. This sigma, yes, this standard deviation defined the shape of this distribution. Yeah? So this is normal distribution. I can write that normal distribution has parameters mu and sigma squared, variance, yes, the mean and the variance. In our situation, this is normal distribution with parameters 30 minutes, yes, and variance equal to 25, because there is variance, no standard deviation, yes. So this is the distribution, yes, of the length of writing of the midterm test, and we would like to calculate this. What percentage of students finish the test within 29 minutes? Yes, our random variable x is the length, yes, for the time, the length for the writing of the midterm test. So I would like to calculate probability that random variable x, yes, the length, the time necessary for the writing of the test will be smaller or equal to 29 minutes. Yes. What percentage of students finish the test within 29 minutes? So we would like to calculate probability that random variable x will be smaller or equal to 29 minutes in our situation. I will use your formulas. Yes, there is written normal distribution, and can you see here probability that random variable x will be smaller or equal to small x2? This is small x2, yes. We will solve this using standardization. We will standardize the random variable x to random variable z, yes. So this will be recalculated like probability that standardized random variable z will be smaller or equal to small z. Yes. How can we solve this? According to your formulas, we will find distribution function phi in point z. Yes, distribution function. This will be calculated like distribution function phi in point z. Okay, and now this distribution function phi in point z is solved using this standardization. Can you see this? Distribution function f in point x is equal to distribution function phi in point z, and this must be calculated like phi in point. x minus mu divided by sigma. This is the standardization. So we will solve this phi in point x. Where is my value x? 29 minutes minus 30 minutes. Mu is parameter of this normal distribution, yes, divided by sigma 5 minutes, yes. So what is here? Here is phi x minus mu divided by sigma, yes. Do you know where I found these values? Okay. So, I will solve this. Minus 1 is nominator, 5 is denominator. So, we must find distribution function phi in point minus 0.2. Yes, minus 0.2. Okay, and now you will need the tables. Of normal distribution. In your tables, statistical tables, you can find a cumulative distribution function for the standard normal distribution. We would like to find distribution function phi in point z minus 0.2. We have calculated in these tables these integrals, yes, these concrete integrals, yes, from minus infinity to z, yes, from this function, and differential is x. Somebody calculated these integrals for you, and you can find the values, yes, in these tables. So we don't have to solve this integral. We will find value z, yes, in the column, and we will find the result, the probability. This distribution, this normal distribution and standard normal distribution is symmetric distribution. Standard normal distribution is symmetric around 0. So we have calculated here only positive, yes, non-negative values. So we will use this formula due to the symmetry around 0. For negative values, these values are given by this formula, yes. So I will find distribution function phi in point 0.2. Here, yes, you can see result 0.57926, yes. Find this value 0.57926. So distribution function phi in point minus 0.2 will be calculated like 1 minus distribution function phi in point 0.2, and we know that this is 1 minus 0. We already found 0.57926, yes. We will use calculator. 1 minus 0.57926. Result is 0.42074. So this is the result, and now we must interpret this. And I will do it here. This probability that random variable x, yes, will be smaller or equal to 29 minutes. It means what percentage of students finish the test within 29 minutes. This is equal to 0.42074. Yes, which can be rewrite in percent like 42.074%. Yes, so this is probability that random variable x, the time necessary for the test writing will be smaller or equal to 29 minutes. Yes, probability is equal to 42.074%. We will continue what percentage of students will not manage the test, will be overtime. Yes, what it means to be overtime. To be overtime, it means that you will need for the test writing, for example, 30 minutes and 10 seconds. Yes, 31 minutes. 35 minutes, 40 minutes, 50 minutes, 1 hour, 2 hours, 3 hours, yes, in the classroom, 5 hours, 1 day, hungry, thirsty, yes, in the classroom, etc. We don't know where is the end, yes. We don't know where is the end. We just know that we would like to calculate probability that random variable x will be higher than 30 minutes. Yes, the student will be overtime. And because we don't know where is the maximum, the potential maximum, somebody, yes, is not able to manage the test ever. Yes, so it will be better to calculate this like 1 minus probability that random variable x will be smaller or equal to 30. Yes, and according to this standardization, yes, and this calculation, we will solve this example, this B point. Yes, this is again some small x2. Yes, we will use this probability, this standardization to variable z, and I will calculate probability that variable z will be smaller or equal to small z using this standardization process. I must calculate distribution function phi in point x minus mu divided by sigma. In our situation, this will be phi in point 30. There is x2. Yes. There also was x2. Yes. This value. So 30 minus mu, the parameter of the distribution, 30, divided by standard deviation 5, yes? Result is distribution function phi in point 0, yes? Distribution function phi in point 0. So, you can, again, check your statistical tables. Yes, and you can find here this cumulative distribution function for the standard normal distribution, and z is equal to 0. So this is the first value in this tables, yes, and the result is 0.50. 0.50. So 1 minus 0.50 is equal to 0.50. Yes, and this can be interpreted like 50%. Yes, 50%. Okay, so there is solution of B. There is 50% probability that student will be overtime, yes? Or we can interpret this like 50% of students will be overtime, yes? 50% of students will not be able to finish the test, yes, within the time limit. It's horrible, 50% of students, yes? So, I would like to calculate how much time is needed for preparation, for writing of the test, so at least 95% of all students, yes, is able to finish the test. I would like to know the time necessary for 95% of students, yes, for the successful writing of the test. In your formulas, please find the formula for calculation of quantile. This small formula, yes? This small formula in the middle. I will use new paper and we will solve this. xp is equal to mu plus sigma zp. Okay, what is here? I would like to calculate x 0.95. There is probability, percentage, yes? 95% of students, yes, must be able to manage the test, yes? And this will be equal to mu. Parameter mu, parameter from normal distribution 30 minutes, yes? Parameter of this distribution plus sigma, standard deviation, the variance, second parameter of the normal distribution, sigma squared, 25, yes, is parameter, and sigma is standard deviation, 5 minutes, yes, we know these two informations, times z, we must find quantile. We must find quantile z 0.95, 95% quantile, 95% quantile of the standard normal distribution. Yes, this is probability. Yes. This is probability. In the previous two examples, 2 points, yes, we checked these columns, yes, we checked these columns, or these columns, yes, or these columns, and we find a probability in the next column, yes. Do you remember distribution function phi in point 0.20 was equal to this value, and this value is probability. And now I can find a probability here in this column, yes? So trying to find here 95%. Can you see this last value? 94.4%, 0.94408. I need next table. Yes, I need next table, and there you can find, for example, this value 0.95 and something small, 95053. Yes. Okay, so the size of this quantile is 1.65. 1.65. So this is equal to 1.65. Or you can use these better tables, yes? Can you see quantiles of the standard normal distribution, ZP? So you need to find here the p-value, the probability, yes? You have recalculated here the probability on 3 decimal places. Can you see here? 95.0% p-value here, 0.950. And the size of this quantile is 1.645. So here you have 3 decimals, yes? So you can use this exact value, 1.645, yes? So it's not necessary to use this value is 2 decimals only. We can use 1.645 with 3 decimals, yes? But you can see that it's almost the same, yes? Okay, so 30 minutes is the mean, yes? Plus 5 times 1.645. And result is the time necessary for 95% of students as able to write the test. So 30 plus 5 times 1.645, enter, 38.225 minutes. Yes, so this is the result. More than 38 minutes, yes, is necessary for 95%. At home, you can try, for example, to calculate how many time will be necessary for 99 students, yes, for the successful writing of the test. Only one difference, only one change will be here in the case of this quantile, yes? So you can use either this table for searching cumulative distribution function, yes, but you must use probabilities, and the size of the quantile is here, or you can use these exact values with 3 decimals, quantiles of the standard normal distribution, ZP. We'll continue with another example. When observing the lifetime of new batteries, a random sample of 30 batteries was drawn from a population of 50,000 batteries. Using this sample, yes, using those 30 batteries, the sample arithmetic mean, the mean calculated from this sample of their lifetime equal to 195 days was calculated. Further, the standard deviation of the batteries lifetime is known to be 20 on the basis of long-term observation. The lifetime of a battery is assumed to be a random variable which follows the normal distribution. Okay, so what's written here? It's necessary to know that we have this capital N, for example, equal to 50,000 batteries. Yes, you ordered, yes, these batteries in some factory, for example, yes, and you wanted to test these batteries, so you selected N equal to 30, yes, you selected 30 batteries from this population, so you have observation x1, x2, x3, until x30. Observation of what? You used these batteries, for example, in the wall watches. Yes, for example, in the wall watches, and you observed the lifetime. Yes, so there we have the wall watches, and you observe that this battery, yes, will be able to work in these watches, I don't know, 200 days, yes? And this battery, for example, 180 days, yes? And this battery, for example, 210 days, yes? So you observed the lifetime, yes, of these batteries, for example, in the wall watches, and according to this observation, you calculated the point estimate. Yes, the point estimate, the mean, yes, the sample mean, which is equal, according to this example, yes, using those 30 batteries, using this sample, arithmetic mean of their lifetime equal to 195 days was calculated. Yes? So you calculated 195 days. Yes? So this is very important information for you. Further, the standard deviation of the battery's lifetime is known to be 20 on the basis of long-term observation. I will check your formulas, and we can find here formulas for construction empirical interval population parameter estimates. You can see that almost everywhere, or mainly here, yes, you have written sigma squared. known, sigma squared unknown. In this situation, there is written something about deviation. Second power of the deviation is variance. Standard deviation of the batteries is known and is equal to 20 days. So this sigma, which is equal to 20 days, is not connected with this sample of 30 batteries, but this sigma is connected with this population of batteries. It's some measure of quality of these batteries. So in our situation, yes, the variance or the standard deviation, yes, of the lifetime of batteries is known, because this 20 minutes is connected, yes, with this population, and it's based on long-term observation. So we know that we have calculated mean and known sigma or known sigma squared. Okay, so the lifetime of battery is assumed to be a random variable which follows the normal distribution. What it means, there is a normal distribution of battery's lifetime. There is the mu, the mean. In our situation, the mean is around 195 days. Yes. Okay, we can find battery. Yes, we can find battery which will be able to work in these wall watches, for example, 100 days only, and we can find battery, yes, which will be able to work in these wall watches, for example, 300 days. But most of batteries will be concentrated around the mean, yes, around this mu, this expected value, yeah, this average. So what can we calculate now? Calculate a 95% two-sided confidence interval for the expected value of a battery's lifetime. Okay, so we have some parameters, yes, and we would like to calculate a 95% two-sided confidence interval for the expected value of battery's lifetime. So I will check your formulas, and there is section constructed empirical interval population parameter estimates, population mean expected value, yes. This is our situation, normal distribution in population, two-sided confidence intervals for parameter mu. And you can see there is written sigma squared known, sigma squared unknown, yes. In our situation, the variance or the standard deviation, sigma, is known, yes, is known in the population. So I will use this first formula. So what's written here? Here is written left side mu or x with stripe, the mean, yes, the mean, minus z1 minus alpha divided by 2 times, in our situation, sigma, known sigma, divided by square root of n, yes, and right side, x with stripe, so the mean plus z1 minus alpha divided by 2 times sigma divided by square root of n. Okay, so the power of this interval, yes, the confidence level of this interval is every time 1 minus alpha, yes, 1 minus alpha, and we must calculate 1 minus alpha equal to 0.95, 95% confidence interval, yes, 95%. But you know that in statistics we are never using percentage, yes, for calculation. So instead of 95%, we must use this 0.95. And this 0.95, yes, according to presentation given by Mr. Hellman, you know that this is 1 minus alpha, yes, the confidence level. So we know that alpha is equal to 0.05, and this alpha is very important for us because this alpha is also used here in the left side of this interval or in the right side of this interval, yes? Because we know, according to these calculated parameters and given parameters in this example, yes, we have calculated a sample mean 195 days, yes, minus, and there is quantile of the standard normal distribution z, 1 minus, and no alpha, but alpha divided by 2, because this is two-sided confidence interval. So there will be z, 1 minus alpha, 0.05, divided by 2. Alpha is written here, yes? 1 minus alpha, the confidence, is equal to this. So alpha, yes, 1 minus 0.05 is equal to 0.95. So you know alpha, yes? So alpha is here, times sigma 20 days divided by square root from the random sample of 30 batteries, yes? So this will be the left side and right side. 195 days plus the same quantile of the standard normal distribution z, 1 minus 0.05 divided by 2 times, again, sigma 20 divided by square root from 30. Yes? So the last important thing for us is to find this quantile. 5% divided by 2 is 2.5%. 100%, 1 minus 0.025 is 0.975. Yes, for us it's necessary to find that 0.975, 97.5% quantile of the standard normal distribution. Yes, in the statistical tables, yes, you can find these values here, p-value here, 0.975, 97.5% quantile is equal to 1.96. So we will use this value 1.96, yes, and we will use this value here and here, yes. So this will be here and this will be here. Okay, and now I can use calculator, yes, and I can solve this issue. So 20 divided by square root from 30 times 1.96, and finally this value 195 minus this calculated result. So on the left side you can find 187.84 days. Yes. And right side, yes, will be calculated like 20 divided by square root from 30 times this quantile 1.96 plus the mean 195, enter 202.16 days. Yes, days. Okay, so this is the confidence interval, and this is the response. This is the response on A. Calculate 95% two-sided confidence interval for expected value of a battery's lifetime. Yes, in 95% of all observation, all samples, yes, we can expect the mean. We can expect the mean between value 187 days and 202 days. Yes, so this is confidence interval. You can continue and you can calculate 95% two-sided confidence interval for expected value of a battery's lifetime if the population standard deviation was not known. It means using the standard deviation calculated from the random sample, its value being 30. What it means? Can you see this paper? There was written that this sigma equal to 20 is connected with the population of batteries. Now I don't know this value anymore. Yes, I don't know this value anymore. I have here calculated the sample mean. Yes, and somebody for me calculated sample standard deviation. Sample standard deviation. What is standard deviation? Standard deviation is square root from the variance. Square root from the variance. Variance is summation through all E. I have here xe minus x with stripe, the mean squared, yes, and this variance is divided by n. But now this is mathematical statistic, yes, and this is sample standard deviation. If you check your formulas from the beginning of the semester, you talked with Mr. Hellman about a sample variance and sample standard deviation, and this sample variance and with square root is deviation, that is -1. Yes, so somebody calculated, yes, on the basis of this data set, which is unknown for us. Yes, I don't know this data set. Somebody calculated this sample mean and this sample standard deviation, which is equal to 30 days. Yes, so now we know only the sample standard deviation and not this deviation connected with the population. So I must use the formula where is written that we have unknown variance or unknown standard deviation. So I will write this formula on the paper. What's written here? X with stripe minus student t quantile 1 minus alpha divided by 2 times standard deviation from the sample divided by square root of n. So this is left side. Right side, x with stripe plus student t quantile 1 minus alpha divided by 2 times deviation divided by square root of n. Okay, and I must calculate again 95% confidence interval. This confidence is 1 minus alpha. Yes, so again alpha is equal to 0.05. Do you know which quantile will be necessary to find in the tables? Student t quantile 1 minus 0.05 divided by 2 so this is equal to 0.975. 97.5% quantile of the student T distribution with degrees of freedom ni. This is small Greek letter ni, which is calculated like n minus 1. Yes. In our situation, 30 batteries minus 1 equal to 29 batteries. Yes. Number of degrees of freedom is ni. Okay, so please check your tables. Check tables with student T quantiles. Here you can see quantiles of the students distribution TP. P value in the middle is 97.5%. 97.5%. And this is not V, this is ni. This is small Greek letter ni. And 29 degrees of freedom you can find here at the bottom. Yes. So in this column you can find value of this quantile 2.045. Yes, 2.045. So this quantile is 2.045. And now we know everything for calculation. Yes, 195 days minus 2.045 times 30 days divided by square root from 30. And right side is equal to 195 days plus 2.045 times 30 divided by square root from 30. Yes. Okay, now you can use the calculator. And I will start with this ratio. 30 divided by square root from 30 times 2.045. 195 minus this value. Left side, yes, 183.80 days. Okay, and right side, 30 divided by square root from 30 times this quantile 2.045 plus 195 days, the mean 206.20. Okay, so this is again in days. Yes, this is 95% confidence level, 95% confidence level for the situation that the standard deviation is unknown, and we have calculated standard deviation from the sample, which value is equal to 30 days. Okay, how would the confidence intervals differ if all the calculations were carried out on the basis of a random sample of 100 batteries instead of 30 batteries? It's very important to know that if you check the tables, yes, if you check the tables with student distribution, student quantiles TP are tabulated to 30 degrees of freedom. Yes, ni is equal to 30. If we have more degrees of freedom than 30, the values of these quantiles are very similar to normal quantiles, to quantiles of standardized normal distribution. These quantiles, yes, quantiles of the standard normal distribution. So we will recalculate the quantile, the confidence interval. We will recalculate the confidence interval, this one. X with stripe minus z 1 minus alpha divided by 2 times sigma divided by square root of n, left side, and right side, x with stripe plus z 1 minus alpha divided by 2 times sigma divided by square root of n. Yes? So, we will calculate again 95% confidence interval, yes, but instead of n equal to 30, we will use n equal to 100, yes? Do you remember we have sigma equal to 20 days, yes? Our 1 minus alpha is equal to 0.95, yes? So alpha is equal to 0.05, perfect. So what is the difference? We will use the same quantile z 0.975. Why? Because I calculated this like 1 minus 0.05 divided by 2. Yes? And this quantile, this 97.5% quantile of the standard normal distribution is 1.96. Yes? Do you believe me? In your tables here, that P is 1.96 here. Okay, so where is the difference? The mean 195 days, yes, minus 1.96 times 20 divided by, and there is the difference, square root. Instead of 30, you will use value 100. 100 batteries, yes? And right side, 195 minus 1.96 times 20 divided by square root. And what is here? Instead of 30, there is value 100. Yes? So, we can solve this confidence interval. Use calculator 20 divided by square root from 100 times 1.96. 195 minus this calculated value. Left side, 191.08 days. Yes? And right side, 20 divided by square root from 100 times 1.96. I'm sorry, there is plus, yes. The right side, 20 divided by square root from 100, yes, times this quantile, 1.96. There is plus sign, because there is minus sign. Left side is minus, there is plus. So plus the mean, plus 195. And the result is 198.92 days. Yes. So this is situation for n equal to 100. yes, and I will find here, there is some historical paper, yes, the previous paper where I have n equal to 30, yes. Can you see the difference? If you have n equal to 30, you have this range of confidence interval. If you have n equal to 100, you have tinier of this confidence interval, yes? So if you increase the sample size, you have tinier confidence interval. And we can continue with D. How would the confidence intervals differ if all the calculations were carried out under a confidence level of 99% instead of 95%? We have here confidence interval 95%. So I will use this one. This is my 95% confidence interval, yes, and I will recalculate this confidence interval to confidence interval 99%, yes, n equal to 30, and 99% confidence limit. So I will use another paper, yes, and on this another paper I will write a formula. X with stripe minus z 1 minus alpha divided by 2 times sigma divided by square root of n, yes. Okay, and here x with stripe plus, yes, correctly, plus z 1 minus alpha divided by 2 times sigma divided by square root of n, yes. So confidence level, confidence interval is 1 minus alpha. So there can be 0.95, yes, we calculated 0.95, and now I will calculate 0.99, 99% confidence level. Therefore, alpha will be equal to 0.01. Only 1% alpha. Where is the difference here in this calculation? In the case of this quantile, yes, z 1 minus 0.01 divided by 2, result is 0.995, yes. So we must find 99.5%, 99.5% quantile of the standard normal distribution, yes, from the tables. So you can check the statistical tables, and 0.995, yes, there is p-value, column with p is here, and the size of this quantile is 2.576. 2.576, yes. So instead of this quantile z 0.975, which was equal to 1.96, yes, we will use this quantile, yes. So we will not use this quantile, but this quantile. Okay, so the mean 195 minus 2.576 times sigma. Original sigma was 20 days divided by square root of n. Yes, square root from 30. Yes, I will use original value square root from 30. Okay, so this is the left side. Right side, 195 plus 2.576 times 20 days divided by square root from 30. Okay, so I will use calculator, and here 20 divided by square root from 30 times 2.576. 195 minus this result. On left side, 185.60 days, yes, and right side, so this is in days, and right side, 20 divided by square root from 30 times 2.576 plus 195. 204.41 in days. Yes. Okay. So this is 99% confidence interval. Yes. For the case of n equal to 30 and known sigma, yes, and I will rewrite here, or I will show to you here the situation where I have n equal to 30, yes, n equal to 30, confidence level is 95%, yes, and known sigma. Can you see the difference? If you require higher confidence, yes, you have a wider confidence interval. So this was situation of 95% confidence interval, and if you want 99%, so this is the development, as this is development of 99% confidence interval, yes, using the same conditions, the same n sample size and the same sigma known standard deviation, yes. Confidence interval is wider than before. I will solve this example. 500 products were randomly selected from a large delivery of 10,000 products, 378 of them being of premium quality. I ordered a population of 10,000, for example, LCD displays. Yes, I ordered 10,000 displays, and I performed a random selection. Yes, random selection from this large delivery. Random selection n is equal to 500, yes, and I found here, I can denote this, for example, like m, yes, equal to 378 of them of premium quality, yes, they are not damaged, for example, yes, I ordered displays, yes, and these displays are not broken. If I selected 500 boxes, I opened these boxes, yes, and I found that 378 of them is all right, yes, and then the rest is damaged, for example, yes. We are able to calculate proportion of premium quality products, yes, in this sample, yes, like small m divided by small n. In our situation, 378, yes, premium quality divided by sample 500 LCD displays, yes. So you can calculate 378 divided by 500, yes, and this is the proportion in this sample, 0.756, yes, 0.756, 75.6%, yes. So you selected 500 displays and more than 75% of them is all right, yes. The rest is damaged, for example, yes. Okay, so this was written in our example, and now using 95% two-sided confidence interval, calculate the proportion of premium quality products in the whole delivery. Yes, 95% two-sided confidence interval. We would like to calculate the proportion of premium quality products in whole delivery. I will check the formulas, and I will find this section. Population proportion, large sample, two-sided confidence interval for parameter P. Okay, I will rewrite this formula on the paper. What's written here? Left side, proportion minus Z, 1 minus alpha divided by 2 times square root, and there is proportion times 1 minus proportion divided by n. And right side, proportion plus z, 1 minus alpha divided by 2 times square root proportion times 1 minus proportion divided by n. Yes. Okay, and this confidence interval, yes, has a confidence level, should have confidence level 1 minus alpha equal to 0.95, yes, 95% two-sided confidence interval. Okay, so again, what is important for us? To find a quantile Z, 0.975, 97.5% quantile of the standard normal distribution. You already know that this quantile is equal to 1.96. Yes, we already find this quantile here. Yes, can you see p-value here? On the top of this page, yes, 0.975, 1.96. Okay, so we know everything, yes. We know the proportion, calculated proportion. We know the sample size. So I will write here 0.756 minus 1.96 times square root, and there is 0.756 times 1 minus 0.756, and this is divided by 500 selected displays. Yes? So this is the left side, and right side 0.756 plus 1.96 times square root, and there is 0.756 times 1 minus 0.756 divided by 500. Okay, so I will start here below the root, yes, below the square root. Okay, so 1 minus 0.756 times 0.756 divided by 500 and square root from this result, yes, times 1.96, and finally 0.756 minus this result, 0.7184. 0.7184. This is the left side, yes, and right side. So it's necessary to calculate this. 1 minus 0.756 times 0.756 divided by 500. Square root from this value times this quantile 1.96 plus 0.756, 0.7936, 0.7936 is the result, yes? So this is calculated 95% confidence interval, 95% confidence interval for 95% two-sided confidence interval for the proportion of premium quality products in the whole delivery, yes? Proportion of premium quality products in the whole delivery. In 95% of all cases, in 95% of all situations, yes? So we can expect, yes, with 95% probability that the proportion of premium quality products, yes, will be between 71.84% and 79.36%, yes. So this is your expectation, yes, of the proportion of premium quality products. What else can we calculate here? Construct a 95% two-sided confidence interval for the number of premium quality products in the all delivery. All delivery, what is my all delivery? All delivery N is equal to 10,000 LCD displays, yes? So there is my 95% confidence interval, and you can write here in your formulas count in population, large sample, and noun, two-sided confidence interval for parameter n times p. I will use this capital N, yes, and I will multiply by this capital N the proportions, yes, it will be very easy. So I will use new paper and I will write it here. So on the left side I will have n times 0.7184, and on the right side I will have n times 0.7936. In our situation, n is equal to 10,000 LCD display. So left side is 7,184 LCD displays. Yes, and the right side is 7,936 LC displays, yes? So this is the final response, yes, for this question. Construct a 95% two-sided confidence interval for the number of premium quality products in the whole delivery. In your all delivery, yes, in your all delivery, you can expect, yes, total number of premium quality displays between value 7,184 and 7,936, yes, with 95% of probability, yes. This is the strength, this is the confidence level, yes, of this interval. If you require, for example, 99% confidence level, you can try at home, you can recalculate, yes, you can recalculate this confidence interval. You will see that there will be 6,000 and something probably, yes, and there will be probably 8,000 and something, yes. You know that if you require 99% instead of 95%, yes, the confidence interval will be wider than before, yes, so this will be 99%, and at home you can train, you can practice, you can recalculate this interval to 99% confidence level. We will finish our seminar with this last example. We will use the real data set. Yes, we will use the real data set, use data in the table below, and determine with 95% and 99% confidence level the intervals of average number of achieved points of students from the midterm test of statistics. We have here two groups, yes. We have here females and we have here males, yes. So you can check this sheet, yes, I have printed version of this Microsoft Excel sheet, and you can see that we have here 52 females. Yes, 52 females, and you can see I have here 32 males. Yes, so what is important for us? There is not nobody said here anything about the distribution, yes? There is just written use the data, and we have here the data. We don't know the distribution, but we know that we have here two samples, yes? We have here N1 females, yes? N1 equal to 52 girls, yes, and N2 is equal to 32 boys, yes, so two groups, large group, yes, large two groups, because N is higher than 30, yes, large groups. And we would like to determine 95% and 99% confidence interval, yes, of average number of achieved points, average. So I will check your formulas, and I will find the last formula on this page, which was not used today, yes. Here. General distribution. I don't know the distribution of the population, yes. Variance is unknown, and we have large samples, two samples, yes. N is higher than 30. Two-sided confidence interval for parameter X expected value, yes, for parameter expected value. So I will rewrite this confidence interval on this paper. Yes, so what's necessary to write here? Left side, X with stripe minus standardized quantile, Z 1 minus alpha divided by 2 times calculated standard deviation on the basis of sample divided by square root of n. Yeah, so this is the left side, and the right side, X with stripe plus Z 1 minus alpha divided by 2 times standard deviation divided by square root of n. Yes? Okay, so this is the formula. So what we need, what else is necessary? It's necessary to calculate x with stripe for females, and it's necessary to calculate x with stripe for males. Yes? So the sample statistics, yes? Two important sample statistics. What else is necessary to calculate? Sample standard deviation, yes? Sample standard deviation for females, and sample standard deviation for males. Yes, you can solve this in Microsoft Excel. The mean will be very easy. Yes, you will use a very known function equal sign average. Yes, sample size equal sign average. You will open the parentheses. Yes, you will select the data. You will close the parentheses, and you will press Enter button. Yes, it will be very easy for you. Here we must calculate sample standard deviation. How can we calculate sample standard deviation? Sample standard deviation is different than classical standard deviation. Standard deviation is square root from the variance. Yes, variance is summation through all e, xe minus x with stripe squared divided by n, but this is for the case of sample. So there is n minus 1. Yes, check your formulas from the beginning of our semester and find here the variance or deviation for the purposes of sample. Yes, so in the case of females, you will use here 52 minus 1, and for the case of males, you will use here 32 minus 1. Yes, so there will be 51, there will be 31. Yes, you can try to solve this in Excel, or you can use function. You can use function which is, I hope that I remember this function very well, standard deviation dot s, like sample stdev dot sample. You will open the parentheses, you will select the data, you will close the parentheses, and again you will press enter. Yes, okay, so standard deviation for the sample and average, yes, for the calculation of sample mean. So please try to solve these four statistics in Excel, yes, and check my results, which will be written here. Okay, now I have calculated here the sample mean for females, yes, 16.06 points. There is sample mean for males, a little bit smaller, 15.72. I used only 2 decimal positions in Excel, yes? And there is a standard deviation, sample standard deviation for females, 3.80, yes, and sample standard deviation for males, 3.23. Okay, so we know almost everything. For the purposes of the calculation of this confidence interval, it's necessary to find quantiles. There was written that we must use 95% confidence level and 99% confidence level. Yes, this is 1 minus alpha equal to 0.95. This is 1 minus alpha 0.99. Yes, so alpha here is 0.05 and alpha here is 0.01. Okay, everything is clear. Yes, we will use quantile z 1 minus alpha divided by 2. So we will need quantile, standardized quantile here z 0.975. Yes, and there we will need quantile z 0.995. Yes, so this quantile will be for 95% confidence. This quantile will be for 99% confidence. Yes, you already remember that this quantile is 1.96. If you don't believe me, yes, you can check the tables here. And 99.5% is written here. The size of this quantile is 2.576. 2.576. Yes. So now we know everything. Yes. For example, we will start with females. So females, the mean 16.06 minus for the situation of 95% 1.96. Yes, times calculated standard deviation 3.80 divided by square root from 52 girls. Yes, and right side 16.06 plus 1.96 times 3.80 divided by square root from 52. Yes, this will be 95% and females. Yes, 95% females. Okay, so 3.8 divided by square root from 52 times 1.96 and 16.06 minus this value 15.03. 15.03 is the left side and right side 3.8 divided by square root from 52 times 1.96 plus 16.06, 17.09. Yes. If we change the quantile, we'll obtain 99%. Yes, 16.06 minus 2.576 times 3.80 divided by square root from 52. This will be left side and right side. 16.06 plus 2.576 times 3.80 divided by square root from 52. As this is 99% females. So you can try to solve this. 3.8 divided by square root from 52 times 2.576, 16.06 minus this result, 14.70. So this is the left side. And right side, 3.8 divided by square root from 52 times 2.576 plus 16.06, 17.42. It must be wider than before, yes? And the same for males. So the mean for males, 15.72 minus first quantile 1.96 times standard deviation for males 3.23 divided by square root from 32 boys. And here will be 15.72 plus this quantile 1.96 times deviation for males 3.23 divided by square root from 32. Okay, so this is 95% males, yes, 95% males. Okay, so I will solve this. 3.23 divided by square root from 32 times 1.96, 15.72 minus this value, 14.60. So this is the left side, yes. And right side will be 3.23 divided by square root from 32 times 1.96 plus 15.72, 16.84. And finally, you can try the last one. There will be 15.72 minus 2.576 times deviation 3.23 divided by square root from 32. Yes, and right side will be 15.72 plus 2.576 times 3.23 divided by square root from 32. Okay, so I will write here that this is 99% and males. Yes, so the last calculation will be here. 3.23 divided by square root from 32 times 2.576, 15.72 minus this result, 14.25. 14.25 is the left side, and right side 3.23 divided by square root from 32 times this quantile 2.576 plus 15.72. So you can compare with me the right side, 17.19. Okay, so this is important, this is important, this is important, and this is important. Yes, we calculated 4 confidence intervals. Okay, ladies and gentlemen, so this is the end of our seminar number 10. We solved only 4 examples, but very large and very complex examples with a lot of steps. But this is the end for today. I hope that I will see you next week. So this is the end. Have a nice day and bye-bye.